This is the brief on the XBAR and KAIROS AI architecture. We're looking at a massive shift that turns AI from a basic text generator into a persistent, always-on operating system, using exact math to perfectly sync devices and keep memory absolutely flat. First, let's talk about XBAR and constant, O1 memory space. Instead of AI agents passing written notes back and forth, XBAR lets the executive and memory models share the exact same brain. This beautifully decouples memory from context length by capping sliding window attention and limiting global layers to exactly 4,096 slots. So your memory footprint stays totally flat, whether reading a short email or a million tokens. To guarantee this shared state stays perfectly identical across different hardware chips, it uses exact mathematical primitives, like dual prime CRT NTT, instead of rough estimates. Second, KAIROS tackles time by giving the AI a persistent heartbeat. Instead of wasting computing power during idle periods, it maintains a strict no-op discipline. When inactive, it executes a sub-millisecond coordinate shear to roll back to KV cache memory pointer. Now, won't this rollback accidentally overwrite live data? No way! A clever undo journal saves the state before overwriting and restores it backwards, ensuring perfect control without any corruption. Finally, we have latent space injection and strict project rules. Instead of typing text prompts, you actually steer the AI by injecting concepts directly into its cache using a trained adapter. Moving forward, the roadmap rules are ironclad. Absolutely zero old code contamination, the underlying math primitives are non-negotiable, and all white papers are treated as mutable scaffolding. By separating memory size from context length and replacing text prompts with direct brain rewinds, this architecture makes truly continuous, hyper-efficient AI a reality.